Hi, this is Craig Stocks here for Utah Desert Remote Observatories. You can find us online at utahdesertremote.com. And today we are going to process data for this target, not this data, but this is the target. It's the Eastern Veil Nebula. And I've captured it in RGB with red, green, and blue filters, plus hydrogen and oxygen. So we're going to produce an HOO, or hydrogen-oxygen image, of the Eastern Veil Nebula, and we'll be doing that in PixInsight and Photoshop. So, as always, we'll start in PixInsight, and I've already captured the data and I've reviewed the data through the blank process to make sure everything is good. But just to give you an idea of what we've got, the data was captured, like I said, this was captured for an hourly rental customer. And so he's getting a double bonus because he'll also get a video of the processing. So there's the Eastern Veil, and it was actually captured over a number of different nights. Combination of issues that caused it to take a couple different nights. But it's all been collected here, and I think just the last 4 nights were good. There was a problem with the rotator, and then we had some cloud issues, and it wound up, it took many nights to collect what turned into just a, I don't know, maybe, I think we ended up with maybe 3 or 4 hours worth of data. But we got what the customer wanted. And I have already run it through WBPP, but just to show you how that is set up, go to Script, Batch Processing, Weighted Batch Preprocessing, and I have WBPP configured so it always comes back the way it was, whatever condition it was in or state it was in when I last closed it. So the first thing I'll do is reset WBPP and use the settings from the last session, clear all files, and I'm not going to purge the cache. So we'll need to add lights. So we'll go to the Lights tab, and then at the bottom, plus Lights, and navigate to the folder where the images are stored. And navigate to the right folder where the images are stored. There we go. And this would be, for instance, the most recent night. Load those. And then I actually have data from the 2 nights, I believe, before that that I want to load also. And the Veil Nebula is starting to get pretty low in the sky. So that's also one of the reasons it took multiple nights, is that I couldn't really capture everything all at once because it was low and gradually setting. So I had to, keep going back to finish up to get everything because I only had a couple hours each night before it set. So there's our hydrogen, oxygen, red, green, and blue. And now I need to load the calibration files, and I like to do that by keeping my calibration masters in a folder by themselves. So I can just load directory and navigate to that folder where I keep the calibration masters. And this is the plane wave using the Mono 2 camera. And select folder. And that folder has the master files for the bias, darks, and flats for all combinations that I might shoot with that scope. So it has, for instance, it has flats for sulfur and luminance that we're not using. It doesn't hurt anything to have those loaded. They just kind of go along for the ride. Then the last thing to set up on the calibration tab would be to select the output folder. So again, I keep just a temporary swap files folder, and so we'll use the Eastern Veil folder that is set up for the swap files. And at this point, WBPP is ready to run. Now that WBP has finished, we can open the master files and start working with them. So to do that, I'm just going to double click here on the background, and that'll bring up the Explorer dialog box to navigate to the folder, the swap files folder where we stored the files. And that folder will actually have, in this case, 4 different folders in it for the calibrated data, the registered, the master, and then also a logs folder where it stores the log that PixInsight created. We want to go to the master folder, and we want to open the red, green, blue, oxygen, and hydrogen that were created by WBPP. And now we'll actually start processing these. I'm going to process these actually in a couple different ways or with a couple different stopping points, so that depending on how involved you want to be in the processing, you can do more or less. To start with, let's look at what we've got here. So this is the oxygen, and so I'm going to open the screen transfer function. I normally open it from a little saved process icon that I created over here and saved as a blank project. And the way I created that was by going to Process, All Processes, Screen Transfer Function. And that opens this dialog box. And then you just use the little triangle here and drag out a saved instance of it. And I can right click on that and change the name by using Set Icon Identifier and give it a name like STF2. And so now, rather than going through the menus to open that dialog box, I can just double click on this saved process icon and go straight there. And the little radioactive button here is the one that calculates and shows us what an auto stretch looks like. And remember, it doesn't change the file, it just shows us what it would look like if it were stretched. That's the oxygen, and then the hydrogen, and then the red, green, and blue are going to wind up being combined, so it kind of doesn't matter what they look like individually because we're going to wind up combining them. But one thing I want to deal with, you notice that most of them have some kind of a black stripe over on the left-hand side, and it looks like the oxygen probably has the largest. And that's just because from frame to frame, night to night, the images didn't always, the telescope didn't line up exactly the same way. So when PixInsight registered so that the stars are aligned, that created some misalignment around the edges where not all the frames were photographed the same way. So we're going to fix that before we go any further, and we're going to use a tool called the Dynamic Crop tool, and that's under Process, and you can get to it through All Processes and Dynamic Crop. And the reason we're using dynamic crop is we want to preserve the registration of the stars. So when we crop, we want to crop each image the same. And so I'm going to use the oxygen as the guide. And we have not defined a crop, so my cursor is a crosshairs. And if I just click and start dragging out a rectangle to define a crop region. So there's the crop region I'm going to use. When I release the mouse button, that lights up and that shows me that's how it's going to crop. But I don't want to crop this one yet because I want to apply this same crop, which is now stored over here, to these other files. So I'm going to do them one at a time, and to do that I'm going to use the triangle, which drags out the settings. And so I can apply this dynamic crop to these other 4 images by just dragging the triangle over and drop it onto an image. I'll get a warning that says it's going to invalidate the astrometric solution. Yeah, that's just the way it is. So I'll say yes, and it cropped. Now I'll do the same thing to the next one. And yes, I want to crop it. And number 3. And yes, I want to crop it. And then number 4, so this would be the hydrogen, I believe. And yes, I want to crop it. And now lastly, we need to do that to the oxygen, but instead of dragging the triangle onto the oxygen, since this is the active view, the one that has the crop defined, what I have to do here is use the green check mark to apply this crop. And we're doing it last because we wanted to apply it to the others first. So apply that. Yep. And so now they are all cropped the same, but yet the stars are still going to be aligned exactly the way they should be from frame to frame. Now we're going to use a tool called channel combination, and you can get to that under Process, All Processes, Channel Combination. And let's just reset it. And what we want to do, we're going to play with this twice. Typically, I would use it to combine the red, green, and blue to create an RGB color image. So to do that, I'll use the drop-down menu here, and I'll select that I want to put the red image in the red channel. Click OK. And I want to put the green image, the one taken with a green filter, in the green channel. And we want to put the blue in the blue channel. So now we have red, green, and blue assigned for red, green, and blue. I click the solid circle in this case to execute this process, and it'll create a new RGB image. And you can see it's new, and we can see that this is tagged as an RGB where the others are gray. So we're done with channel combination here. And if I want to see what that looks like, I can use the screen transfer function, click the radioactive button, and get a stretched preview. And sometimes these will come out with a really obvious color cast. In this case, it's pretty neutral. But we're actually done now with the individual red, green, and blue. So I'm just going to close those three files. And it's warning me that I have made changes because I have cropped each one. So I'm confirming, yes, I really want to close it. So now we have three views to work with. And I'm going to tile these so we can see all three at once. So here's our color image that we created. Here's the oxygen, and down here is the hydrogen. So a couple things you could do. If you're happy with the RGB image and you don't want to do anything else, I could just go to File, Save As, and save this image, give it a new name, change the folder, save this as the Veil RGB, and consider myself done. I mean, that's a perfectly legitimate way to process it. We're not going to do that, but if that's all you want to do, that's fine. We can also do something similar with the hydrogen and oxygen. I said we're going to produce an HOO image. And what HOO means is HOO is assigned to red, green, blue. So hydrogen is going to be red, oxygen is going to be both green and blue. And actually we can do that with the channel combination tool again. And in this case, we're going to assign hydrogen to red. And then we're going to assign oxygen to both green and blue. So there's oxygen in green. And again, we'll choose the same oxygen for blue. So now we have hydrogen, oxygen, oxygen assigned to red, green, blue. Click the solid circle, and that will create an HOO image. And we can, again, use the radioactive button and see what it looks like. In this case, we have a pretty strong color cast probably because we used both the oxygen for both green and blue. But that's going to get fixed as we move along. So I'm going to go ahead and update my arrangement so we can see all four. So here's our HOO image, here's the RGB, hydrogen and oxygen. If I really want to keep track of this, I can right-click on the image and change identifier and label this one as HOO and label this one as RGB. So there's a lot of things we could do at this point. The process I normally work through is I will use some form of gradient correction. And we've trimmed these up so they're nice and neat. So I'm going to use the Graxpert tool. And I'm going to use a trick here because I want to apply Graxpert to each one of these. So 4 times. And rather than sitting here and applying them one at a time, I'm going to create a process or an image container that represents all 4 of these images. And I'll do that by right-clicking on the background, choose Image Container, I'll reset it, and then This icon will let me choose or add views, which is what I want to do. And there are the 4 views, and I'll just select all, click OK. And now we have all 4 of these views listed here. So I can now, rather than dragging, for instance, rather than dragging the Graxpert saved process icon onto each image one at a time, I can drag this image container triangle onto the Graxpert process icon. And now PixInsight is going to go through and run Graxpert one after the other on each one of these 4 images while I take a short break. Now Graxpert has finished running, and notice right away the HOO image that I created directly from the hydrogen and oxygen data. Notice how much more intense the color is, how much more detail it has compared to the simple RGB. And that's kind of the nature and the function of narrowband images. The narrowband filter blocks out everything except just the color of the element that you want. In this case, hydrogen and oxygen, 2 different filters. So you get a cleaner image of the hydrogen and the oxygen without the effects of light pollution. It also has a tendency to make the stars smaller, which in this case is a nice plus. So we'll continue our processing. The next thing I want to do is some color correction, but I need to do a couple things first. I'm first going to run Blur Exterminator on the RGB image, and I want to run it in correct only mode. And what that means is, and I'm using a saved process icon, that I've checked the box correct only. So it's going to correct the stars without trying to sharpen the nebula. So I can apply that, and this will take about 30 seconds for it to run. And the effect that you'll see is the stars will get smaller when it's done running. So Blur Exterminator has finished, and if I go back and forth, this was the before and this is the after. Not a huge change, but it tightens up the stars a little bit, and if there had been some minor tracking problems, it would have cleaned that up also. Now I want to do color correction, and to do that I'm going to use spectrophotometric color calibration. There's a little bit of a problem with that though, because it requires an astrometric solution, and if you remember when we did the dynamic crop, that removed the astrometric solution. So we need to create a new solution. We need to image solve this image. So I'm going to make sure the RGB image is selected. I'm going to go to Script, Image Analysis, Image Solver, and basically in this case, because these are FITS files captured from an automated telescope, all of the right ascension and declination time, all of the information is correct in here. It knows the focal length and the pixel size. So all I have to do is click OK, and it will automatically have the right settings. If I had been using a DSLR or a system or process that didn't create the right data in the FITS header, then you might have to do a search for the target that's included in the field of view, so that the image solver knows what it's looking at and has a good starting point. So it's not trying to find this target somewhere at some scale in the entire sky. So it just speeds up the process and makes it solvable versus unsolvable. And this is just about done. So it's going through the iterations now of finding the best match. And I'm going to pause for a minute. Somewhat unusually, the image solver failed, and I know that because it ended with an error rather than with a result. So that's something to keep an eye on when you're running image solver. If it fails, you want to keep an eye on that. So I'm going to undo the Blur Exterminator, and we'll try it again. Sometimes that in itself will solve the problem. This is the problem with running through a process, kind of cold. If we didn't have the right ascension and deck and so forth, you could go into search and search for the catalog number of the Eastern Veil Nebula. That's how you would approach it if you didn't have the astronomical data. So we'll let this run. Well, this has turned into an interesting challenge. Um, I tried running the image solver a couple different ways against the data, and it just didn't want to resolve. Even removing the crops, that dynamic crop didn't solve the issue. So what I've done is probably what I should have done in the first place, is we'll just ignore these. And what I did was go back and rerun WBPP, and there's an option on the lights panel for auto crop. And what auto crop does is it automatically does what we did with the dynamic crop. It figures out where the cleanest edges are of the images and calculates or applies an automatic crop. And you do that with this checkbox on the Lights tab under Image Integration Options. I normally don't have that checked because I prefer to control the cropping. In this case, it's a good solution to the problem because the WBPP process does a plate solve of the best image. So it gets a good image solution or astrometric solution and applies that to all of the master lights. And with the auto crop, it still retains that astrometric solution. So the starting point then, when you run this, it creates two different versions of your images. So here's our red, green, and blue, hydrogen, and oxygen. And you can see that these have an auto crop tag on the end. And you may also notice that the images are twice the size. But if I open these, you'll see that each one actually has two images in it. And then one of them we don't need and one of them we do need. And if you look at the titles, so for instance, this is the oxygen, and it says auto crop mask, and this one says auto crop integration. So the ones that say auto crop mask, and you'll be able to see there's a kind of slight outline here that shows where it was cropped. We don't need those. So I'm just going to close the ones that say auto crop mask, and hopefully I will do these correctly. If I screw this up, I'll have to go back and start over. Okay, so here are our 5 auto crop images, and we have already basically done that dynamic crop by doing the auto crop. So we can jump straight into Graxpert or gradient correction or whatever tool you want to use for overall gradient removal. So I'm going to go ahead and create my image container, and I'll have to clear this and start over. There are the 5 images. And actually, I'm going to go ahead and take a little bit of a shortcut. There's no point keeping the red, green, and blue individual. So I'm going to go ahead and combine the red, green, and blue. So we will put, just like before, we'll put red in the red channel. We will put green in the green channel. And we will put blue, obviously, in the blue channel. And create our RGB image. And now I can close the channel combination, and I'm actually done with the red, green, and blue individuals. So now we just have these 3 images that we're working with. And as I did before, I will arrange these as a tile. So there's the 3 images. And I want to create an image container now for these 3 images. So I'll just reset the list. There are the 3 files that I want. Click OK. And now we can run our Graxpert or gradient correction or dynamic background extraction, whatever your method of choice is. I tend to use Grexpert probably more than the others, so we'll just let this run. Grexpert has finished now, so the next step is we want to apply color calibration to this RGB image. So I have a variety of saved spectrophotometric color calibration settings. This is with the monochrome camera with red, green, and blue filters. And if I just double click on this to open it up, you can see that the settings here are specific, that it's the Sony sensor and the astronomic red, green, and blue filters. So we'll just apply this, and it will do the spectrophotometric color calibration where it calibrates the star colors based on the Gaia catalog of stars. So this is done now, and we get this chart that shows how well it was able to white balance and match the colors of the stars. Basically, the straight line is the ideal. The scatter plot of green dots is how well the individual stars match to the color, the ideal color that they should be. So it did a good job. You'll also notice that the brightness of the image changed, and that's because we're still looking at the same view, but we have not updated our screen transfer function tool that brightens a preview so that we can see what's going on. So to do that, we need to update the screen transfer function by clicking on the radioactive button, and then it'll recalculate how much it needs to brighten this so that we can see it on the screen. And that's what it looks like now. And like I said before, you could, this makes a perfectly good image. You could apply this screen transfer function and save it, and you're done. We can also apply the channel combination to the hydrogen and oxygen, and let's just do that real quickly. I'll just pull up channel combination, and we're going to create an HOO image, which means we're going to have hydrogen in the red, and then we're going to put oxygen in the green and blue. Put the solid circle, and that'll create the new image. And we'll just do an auto stretch preview to see what that one looks like. Again, I'll do the tile, just update the tile window so we can see all four. Now, we want to run color calibration on this image also. And we're going to do that a little bit differently. And this isn't, I'm going to tell you, this isn't actually the proper, correct way to do it, but it works plenty well enough. I'm going to open up this color calibration for the mono camera, and I'm just going to click on the narrowband filters mode. And that is, as they say, close enough for government work. It will calculate reasonably well for hydrogen and oxygen, and we'll just apply that to this image and get the color calibration. In case I didn't make it clear, because the autocrop retained the astrometric solution, we don't have to go through that process of creating a new astrometric solution or using image solver with these images. That carried along from WBPP. That was the advantage of using the autocrop feature in this case. So that's done. I'll close this, close the spectrophotometric, update the screen transfer function. And now that we've applied spectrophotometric color calibration, it's fairly important to keep this link checked so that it does a linked stretch rather than an unlinked stretch. A linked stretch, it stretches each of the red, green, and blue channels the same amount. In an unlinked stretch, it stretches the red, green, and blue channels to the same relative brightness level. And in this case, we've already color balanced, so we want to maintain that by doing linked stretches. Now, again, you might already decide that this HOO image looks good enough that you're ready to just save that and move on. We can change the identifier to keep track of these. So there's our HOO image, and here is our RGB image. The next step in processing is to apply some sharpening, and I want to do that again using the image container, and I want to add the HOO image to the list. So I'm going to again click on the Add Views. There's the HOO image. I can just double click on this one and OK, and now it has added that one to the list, so we have all 4 images listed. And I will just drag this to my Blur Exterminator saved process icon. I could also start this individually from Process in Blur Exterminator, and we'll just let this run. Blur Exterminator is done now, so the next step is to stretch these images and actually apply the stretch. And I'm going to do that using the screen transfer function because it gives you a very good starting point for working with the images in Photoshop. So I will choose from my saved process icons the histogram transformation tool. And we'll just start here at the top left. I'm going to update the view. Now, what I typically do is fine-tune this a little bit by eye. And to do that, let me just reset this and we'll start from scratch because it'll be a little bit easier to see. You probably can't really see it very well, but there's a little slider over here. It starts out with 3 sliders, much like you can see at the bottom, with one at the black end, the midpoint, and the white end. And when you do the stretch, and since this is a linked stretch, it's calculated for red, green, and blue. And there's actually 2 sliders jammed up against the left side here. So what we need to do is kind of zoom in on this part of the scale. So to do that, I'm going to click on the plus icon here and hover over the left-hand side. And when I click, it's going to start zooming in, not into the image, but into these sliders. And eventually I can put the plus between the 2 sliders and spread them out. So now we have zoomed in and we're looking at just the very left end of these, this scale. Now I can go back to the arrow, and if you look at this image, which is the active image, if I move the left slider, which is the black slider, if I move it to the right, it'll make the blacks a little darker, which is, I want to make them darker but not completely black. And I'm kind of visually comparing that black to this black because this is a pure black, and I don't want this to be completely black over here. And then I may want to brighten the whites a little bit, but I don't want anything to be too bright. I don't want anything to be pure white. I'm just brightening the midtones. So that looks okay. To apply that, I'll drag the triangle from the screen transfer function window down to the bottom of the histogram transformation tool, drop it there, and you may have noticed that this curve changed. It was a straight line, now it shows a curve, and we're looking at the composite RGB where all 3 are stretched the same. Now if I just click the solid square to apply it, this image will turn white, and that's because we've stretched the image and we're looking at it through a stretch preview. So we are actually stretching it twice. We'll just leave that white for now so that it's a reminder that we've already stretched it. And I'll move on to the RGB. Again, I'll update the view. And I will tweak these sliders just a little bit. We were already zoomed in to a pretty appropriate spot. Drag it down to the bottom and we'll apply that. It'll turn white. We'll move on to the next one. Update the preview. Darken the darks a little bit. I don't want to brighten the whites too much. And this is a grayscale image, obviously, but we're going to turn it into color in Photoshop. So we'll apply this. And then the oxygen down here will be the last one. Now here, we can't see the sliders, so I'm going to go to the, let me just do a reset. So we'll update the view. Oh, I'm still on the wrong, I need to click on this image. Update the sliders, and now we'll have to zoom in again. So my problem was I was still on the image that I had just stretched. And go back to the arrow, darken the darks, brighten the brights. This is actually the mid-tone slider. And you notice I'm not moving it very much. And if this seems too fussy to you, you can just skip this step because it'll still work just well enough in Photoshop. We'll apply this. And now I want to turn off the screen preview for each one of these. So I'll use this icon on the top toolbar to enable or disable the screen transfer function. I can also use F12. So now you'll notice we see the image as it should be, and we don't have a green bar. We'll come to this image, press F12, click up here, F12, here, F12, and those are our 4 images. My almost last step is I want to run Noise Exterminator and Star Exterminator for each one of these images. And I have Star Exterminator configured so it will save the stars using the unscreen process. So to run those processes, I'm going to use, again, my image container. I'll drag the triangle over to a process icon and let it run. You can also just run each process or each step on each file one at a time, and that works just fine. We'll let this run, and when we're done, we'll have 4 starless images and 4 images of stars. The Noise Exterminator and Star Exterminator have finished, and we are done with our image container, and we are done with the screen transfer function. You can see the tiled images back here. We have 4 starless images, and we also have 4 images of stars, and now we just need to work our way through and save what we want to save. So the RGB stars are particularly valuable because these have the best color rendition of the stars. We may actually like the shape and size of the stars better from somewhere else, but this has the right color. So we're going to save this. So I'll just go to File, Save As, and I'm going to save this in the same folder that we were just working in. So this was the Eastern Veil. I'll just save it. I'll save it in the master. And we're going to save it as a TIFF file. And this is named RGB stars. And I want to change this to 16-bit unsigned integer. Click OK. And now I'll just iconize or minimize this. These are the HOO stars. And these have similar color. But they're smaller stars, and I like that. If you're in Hollywood, you want to be a big star. I like small stars. So I'm going to save this also. So File, Save As, and again, we'll save this as a TIFF, and change the bit depth to 16-bit. I'll minimize this. These are the individual oxygen and hydrogen stars, which I don't think I have a need for, so I'm just going to minimize those. And now I want to save in particular the hydrogen and oxygen files that we ended up with. So we'll start here with the oxygen, and again, File, Save As, and I want to change my file type to 16-bit TIFF. So TIFF and 16-bit, and I'll minimize this. Here's the hydrogen. File, Save As. I know this isn't very exciting to watch. I probably should just pause the video and save these, but you never know when we might run into something interesting. And I also want to save at least the RGB color image. And since we're doing this a couple different ways, I'm going to save the RGB color image, Save As, and 16-bit TIFF on this one also. And normally I don't even create this HOO image, but I did in this case because I wanted to show a variety of approaches. So I'm going to save this image also. If you don't like doing color mapping and you're happy with the HOO image that was created here in PixInsight, this is also a good way of processing the image. So again, I'll do File, Save As, 16-bit TIFF, 16-bit, OK. So now we are done in PixInsight and ready to jump into Photoshop. Now, if you've watched any of my tutorials before, you know I always start the same place. Let's start with a simple RGB image. We've separated things, we've done a lot of processing, but among the things we processed was the red, green, and blue into an RGB image, and then we stretched that and separated the stars. But we can put the stars and the image back together if we want. So to do that, I'm just going to go to File, Scripts, Load Files into Stack, and what I want to do is load those two files, those two images, into Photoshop. So this is Eastern Veil in the master. So let's load the RGB and the RGB stars, just these two files. And this is a very simple starting point. Click OK again. There's our RGB stars, and there is our RGB nebula, kind of the background. And if you remember, we removed the stars. I said to choose the option to unscreen the stars. And that's important because now we're going to screen the stars back in. First, we need to change the order of the layers over here. And the way I have my Photoshop arranged, I have the main work area in the center left. And then on the right-hand side, there's the palettes storage, and these are just different, like here's the actions palette, here's the history palette, here's the info palette, different palettes that are stored for quick access. At the bottom right is the layers palette, and this is where all of the various layers will show up. In the middle is the adjustments palette, and I'll be using this to get quick access to individual adjustment layers. Notice I said adjustment layers. We always use adjustment layers. And then at the top right is the properties panel, and this will show the properties of whatever layer is selected in the layers palette. So the first thing I want to do is put the stars on top, so I can just click and drag that layer up to the top. So now instead of having the stars, if you think of it as a stack of paper, instead of having stars down here, the stars are up here, and we're looking at it from above. All we see now is the stars. We'll do a little quick housekeeping. I want to create a layer group. And the easiest way to do that is select the layer or layers that you want to put into the group and use the keyboard shortcut Control-G. That would be a Command-G on a Mac. And you can see that not only created a group, it also put the selected layer in the group. And now I'll just double click on the group name and name this stars. And now still on the group level, the group name level, I'm going to come up to where it says pass through, and I'm going to change the blending mode of this layer group from pass through to screen. And you'll notice when I do that, now we see the stars, but anything that's black, like the background where the stars were extracted from, we see through. And so this has mathematically reassembled the stars and the nebula that we took apart in PixInsight with Star Exterminator. The advantage of that is that now we can process the stars and the nebula independently. So I can, for instance, turn off the stars. I can come down to the RGB layer, and again, Control-G, double-click, name this RGB. And if I want to come down into this layer group and add a levels adjustment layer, I can use the sliders in the properties panel to change the brightness. For instance, I can darken that background, and I want it to be a very dark gray, but I don't want it to be as dark as the surrounding black background here on my canvas. So if I go too far, you'll see that now it's the same color as the surrounding black, and that's too dark. You don't want it to be completely black. You want it to be visible all the way around, kind of like that. And then I can brighten the whites and the highlights, and I have freedom to do this without having any effect on the stars, because the stars are on their own layer. And that's probably about as far as we can stretch the data comfortably. There's a couple places when we stretch it that we can see here. There's a spot where there was a star. We've got some diffraction lines coming in from a bright star. We've got some junk going on down here. and a little bright area in this corner. And if we really want to clean this up, we can correct those. Let's correct, and I'm going to use different approaches on purpose. Let's correct this big star blob by using the remove tool. So I'm going to go over to the healing tools, choose remove tool, make sure we're on the pixel bearing layer, and then I can make the brush larger and just paint over the area that we want to remove, and then press enter or click the check mark, and it has cleaned that up. We can do the same thing with these diffraction spikes. These areas start to impinge into areas where there's detail we don't want to affect, and we have some large areas down here that we want to clean up. So I'm going to just darken these areas and have minimal effect on the other detail. To do that, I'm going to add a blank layer with the icon at the bottom. I'm going to put this in soft light blending mode, and then I'm going to go to my brush tool, and with black as my foreground color, and let's go to about 30% opacity. Any place I paint with black on this blank layer in soft light blending mode, it will darken what's below it. So if I just paint over this area, you can see it just darkened those areas. I can do the same thing in this corner. I'm going to go back to 10% opacity, which I can click the drop down and lower it to 10%, or I can also just tap the 1 key. And now it's going a little bit slower, and it's requiring me to click a few times in each area to have the effect that I want. So in some places we have darkened the background quite a bit, and if we make it brighter, then we just get a lot of noise. So in order to restore a little bit of brightness but a smooth background, I'm going to come above the RGB layer, and to make this easy, I'm going to close the RGB layer, and I'm going to add a blank solid color layer, and I want to add one where the RGB values are 19, 19, and 19. So I could type 19, 19, 19 in each one of these red, green, and blue boxes, or by default when I open this, the hexadecimal value box is selected, and the hex value equivalents are 13, 13, 13. So you may not understand all that, but the short of it is if I type 13, 13, 13, I get 19, 19, 19 for RGB. Click OK. And now when I put this in lighten blending mode, now we have a nice smooth background with RGB values of 19, 19, 19 or brighter. Now I can turn my stars back on. The stars look kind of too big and bold, so I'm going to come to the stars layer and add a levels adjustment layer, and I'm just going to use the levels adjustments to darken the stars, and when you darken stars, you're making them smaller. So let's say something like that, and now I might want to come back and brighten the nebula a little bit. So this becomes an iterative process. But there's a simple RGB version of the Veil Nebula with that data using just the RGB and just the RGB stars. Let's take it a step farther. You could do this same process just like this with the HOO data. So we could go to File, Scripts, Load Files into Stack, and I know this is becoming a long video. If you're still with me, I appreciate it. From the Load Files into Stack, we'll choose Browse, and we'll choose the HOO and the HOO stars. Okay, okay, and now this will create a new document. So this is a new image. There's the HOO color, there's the HOO stars. We'll do the same thing. We'll move the stars on top, put it in a group, change the group name to stars, put it in screen blending mode, and you can see right away having the hydrogen and oxygen data gives us a much cleaner image. We can see more detail. We can see this red streamer up here that you couldn't see in the RGB. I'll put the HOO into a group with Control-G, change the name to HOO. We'll come into the group, add a levels adjustment layer, darken the darks, maybe brighten the brights a little bit. And if you want, you can even play with the color balance. We could add, for instance, a color balance layer and play with the colors. And you have to be a little careful here, because if you use color balance, you will tend to affect the background as well as the nebula. So you have to be a little bit cautious doing it here. But I think that's a better looking image than that one. And that's just by using the HOO narrowband rather than the RGB. Let's go a step further. We've got the individual hydrogen and oxygen that we can use in Photoshop. So this will be the final version. We'll go again to File, Scripts, Load Files into Stack, and this time we're going to load the hydrogen, the oxygen, and I'm holding the Control key, the HOO stars, the RGB stars, and let's load this RGB layer anyway, because I found sometimes it's useful. Click OK, OK again, and so this will be our third Photoshop document. So this is, again, its own image each time you do the load files into stack. And we're going to work with the layers individually. And first I want to get them in order and do the basic housekeeping. So the RGB I'm going to put to the bottom. The two stars layers I'm going to drag to the top. And with both of those selected, I'll do Control G. Those are both in the stars group now. Change the name to stars. And put it in screen blending mode. And we will see whatever stars are on top. So this is the HOO stars, and below it is the RGB stars. I really like the looks of the HOO stars, but I trust the color of the RGB stars more because they're natural color. So the trick I'm going to do here, I'm going to put the RGB stars above the HOO stars, and then I'm going to change the blending mode of the RGB stars from normal to color. So basically what we have now is the shape and size of the star is from the HOO layer, and it's just the color that's coming from the RGB layer. And you may not, I don't really see any significant difference, but I feel better about it. I feel like I've got more accurate color in the stars. And if I feel better about it, then it must be better. Because that's the way art works. If you like it, that's the right way to do it. I'll turn the stars layer off. We have hydrogen next and then oxygen on the bottom. And I typically organize them. The order absolutely does not matter. But just for practical purposes, I usually put hydrogen and then oxygen like this in an HOO image. And the reason I do that is because I always do it that way, and that way as I work further along and the layers palette gets more complicated, I just always intuitively know that the hydrogen's on the bottom and the oxygen's on top. So I'll put each one of these in a layer group. This is the oxygen, and I'll just turn that off for now. We'll do the same thing with the hydrogen, change the name to hydrogen because housekeeping is important. And then I'll put the RGB in its own group, name it RGB, and I'm just going to turn it off for now. This checkerboard pattern, by the way, is Photoshop's code for transparent. Right now we don't have anything visible, so everything we're seeing through something that's transparent, and the way it reflects transparent is by this fine checkerboard pattern. And if you zoom in, you'll notice the checkerboard doesn't get any bigger. As opposed to an image, if it was an image of the checkerboard, the boxes would get larger as you zoom. Let's go back to our hydrogen layer, and we want to set this up to create color, and we want HOO, so we're going to color map hydrogen as red, oxygen as blue-green. The way we're going to do that is I'm going to come into the hydrogen layer, and I'm going to add a hue saturation adjustment layer. I want to click on the colorize box, and you need to do that before you do the other adjustments. We want to change the lightness to -50, saturation to +100%, and then the hue slider is where we decide what color we want this layer to be, and we want it to be red, so I'll just leave it at the red end of the hue slider. And then lastly, we'll change the group, the hydrogen group from pass-through to screen. So it doesn't look any different, but that's because it's the only thing active right now. We'll turn this off, and we'll turn on the oxygen layer, and we'll do the same thing. I'll come in here and add a hue saturation adjustment layer, -50 for the lightness. And the reason -50 is important is that's basically replicates if I were doing this channel by channel. And if you have trouble finding the exact value, you can always just come over here and type it in. 100% saturation, and this we want to be cyan. And so you see I forgot to click colorize. Watch what happens when I click colorize. It's going to reset all the sliders, so I'll have to do that same -50%, and now we'll move the hue up to the cyan color, which if I recall correctly, is 140 is the magic number for cyan. No, that's green. Must be it's somewhere in there. We'll change it anyway, but it's 180 perhaps. It's 180 degrees from red. And now we'll change this to screen. So at this point, all layer groups are in screen blending mode, the hydrogen, the oxygen, and the stars. Now if I come back and turn on the hydrogen blending mode, if you remember, screen lets us look through a layer. If I turn the hydrogen layer back on, we'll see oxygen, but we'll also see through some of it and see hydrogen. And now we have a color image. The beauty of doing it this way is we have virtually infinite control now over the intensity of the red, the intensity of the cyan, the exact color of the cyan. I'll start by darkening the background, and I'm going to come into the layer, and I'll add a levels adjustment layer above the hydrogen layer but below the hue saturation layer. And layer order can be important, especially within the layer group. And you can see, looking at the histogram, between the black slider and where the histogram starts, there's some blank area. The white end of the slider goes almost to the end. But usually I'll slide the black slider over to somewhere near the start of the data, and then the white slider the same way. And we'll do the same thing with the oxygen. I'll move the black slider over, and now what I want to do is move it over such that the background becomes neutral. So it's not predominantly red or predominantly blue, it's just neutral, and we already are going pretty much over to the white end, so we'll just leave that where it is. I'll come back to the hydrogen. I think I can brighten the midpoint a little bit and bring out a little bit more of the red. If we want to play with the tone of the oxygen, we can come to this hue slider, and sometimes it looks a little better if you take some of the green out and make it a little bit more bluish. Sometimes the hydrogen looks better if you make it a little bit more on the yellow side, with just a touch of yellow sometimes looks good. But that, compared to the default, this was the default out of PixInsight. This is what we have working with the files individually. You just have a lot more flexibility working this way. And then lastly, we'll turn the stars on, and there we have a completed HOO image with RGB star colors, even though we used HOO stars from PixInsight. You could continue on doing, basically the kind of processing that you do in Photoshop. Glow, hue, saturation, color balance, colors, sharpening. We can sharpen these layers individually. Basically, whatever you would normally do in Photoshop with a photo, you can do here. And the way I think of it, PixInsight is great for processing astronomical data. Photoshop is great for processing a photo. And really, once you stretch the data in PixInsight and do things like noise exterminator and star exterminator, from that point on, you're really working with a photo and not with astronomical data. So you might as well use a tool that's designed from the ground up and optimized for working with photos. I hope you found this useful. I apologize for the rather meandering tour of problems in PixInsight, but it was probably a good learning experience. If you have any questions, drop those in the comments down below. Be sure to visit our Facebook page at Utah Desert Remote Observatories. You might want to follow us there because we do post blog posts and links to videos and so forth. And with that, I hope you have a great day today and an even better night tonight under a clear, dark sky. Thanks.